Hey guys, here we go. This is our review sheet for quadratics. Midterm review is coming up, so this would also work for the final, or the regions, I should say. So at the top, we have some notes for quadratics. On right underneath it, we have some examples. So you should look through those examples before we start. So if you didn't get a chance, you should look through them now. Hit pause, and then we'll get started. All right, so here we go. Question number 1 it says, solve by the quadratic formula. This quadratic, x squared minus 4x plus 1 equals 0. So we're going to set up the formula. Now, if you forgot what the formula looks like, it's right above. So x equals, and I'm just going to substitute in, so negative 4 plus minus square root negative 4 squared. And make sure you use parentheses if you're squaring with a calculator. Otherwise, just square it in your head, and you probably get it right, over 2 times 1. Plug this in, we get x equals 4 plus minus, and when you work this out, you get 12 over 2. So x equals 4 plus minus, break down 12, becomes 2 red 3, divided by 2. Remember, we can only do the outside like this, right? Never into the radical of the regular number. So 4 divided by 2 is 2, so it's 2 plus minus rad 3. Let's try it again. Solve by the quadratic formula. So x equals negative parentheses negative 8 plus minus radical negative 8 squared minus 4 times 2 times 10. So just remember, just watch it now, right? For this problem, a is 2, b is negative 8, and c is 10. So just be careful. And downstairs we got 2 times 2 in the denominator. 8 plus minus radical negative 16. As soon as I see the negative 16, remember, negative 16s are discriminant. As soon as I see the negative 16, I know it will be imaginaries. So I get 8 plus minus square root of negative 16 is 4i. Put the I at the back, divided by 4. So final will be 2 plus minus I. Let's go to the back. All right, so now it has find the sum and product of the roots. And we have to, first off, we have to make sure it's set to 0 for this problem. So it's going to be, let's get the pen. So it'll be 2x squared, move the x, so minus 3x plus 4 has to be set to 0. And we're going to use our formula from the front. So the sum of the roots is negative b over a. Product is c over a. And from this problem, what we have here, what do we have? We have a equals 2, b equals negative 3, c equals 4. So that's what we're using. Plug it in. So the sum equals negative 3 over 2, which is 3 halves. And the product is c over 2, so it'd be 4 over 2, which works out to be a 2. So that's the sum. That's the product. Next one, we're going to actually use this formula for the sum and product to actually solve the equation. So what I'm going to actually do is physically find the sum first. So the sum is you add the two together, you get negative 8. And I think of it as negative 8 over 1. And remember, the formula is negative b over a. So what we do is we got set up. Then we're going to do product. Multiply, you get positive 15. Set up over 1. That's our c over a. Now we check to make sure that the bottom, the a, the denominators are the same. They are. We're ready to run with it. So from this we can see that a is 1, b is opposite, positive 8, c is keep it, 15. So the answer is x squared plus 8x plus 15. And you must have it as an equation. set it to 0. Let's try the next one. So question number 5. Given the roots r1 and r2, write the quadratic equation, except only we're given r1. But we should recognize this 2 plus 3i is an imaginary, so they occur in conjugate pairs. So r2 has to be 2 minus 3i. Imaginaries and radicals always occur in conjugate pairs for quadratics. So from this, we can actually find the sum of the roots and the product of the roots. So those are the two things we need to find. So the sum is if you add them together, and if you can't do it in your head, use a calculator, but this is pretty easy because it's 2 and 2 make 4. The imaginary part cancels out. So we call that 4 over 1, which is negative b over a. The product of the roots, you could FOIL it out if you want, put parentheses around this and double distribution. 2 times 2 is 4. Minus 6i plus 6i cancels out. Positive negative is negative 9i squared. And what happens with this is that the I squared is negative 1. Change this to positive. The product equals 13. If you had difficulty with that, then feel free to use a calculator. So we get c over a. All the values work out. So I have, from this, I have a is 1, b is opposite, so it's negative 4. C is 13. Ready to write the equation. X squared minus 4x plus 13 equals 0. And that's the equation. Let's try number 6, factoring. So we have 4 types of factoring listed, and so we'll just start off. Now the first one, 6x cubed plus 9x squared. We always look for greatest common factor first. That's what this one is. We take out a 3, that's the number, and x squared. And then 3x squared times what makes 6? X cubed, so it has to be 2x. And to make a 9, we multiply by 3. And that's the first one. Let's try it again. B. 2x squared plus 5x plus 3. Notice we're not solving these. It's not an equation. It's not equal, so I can't solve it. Not equal to anything. So this one, I'm going to do the method that we learned. So we multiply the front and the back. We get positive 6. I keep my signs. So from positive 6, we break down 6 to make the middle term 5. So it has to be 2 and 3. Keep the sign in the middle, it's the bigger number. Since everything's here positive, they're all positive. 2 times 3 makes 6. 2 plus 3 make 5. Divide by the lead with an x, lead coefficient with an x. We reduce if we can. So here 2 cancels, so you get a 1. Notice I keep my sign, I keep my numbers. And then what I do is I just rewrite as x plus 1, read it upside down, x plus 1, and 2x plus 3. 2x plus 3. And that's the factoring part B. So now C. Now some of you might be tempted to just jump right into it, multiply the front and the back. But remember, we always look for a common denominator first. And in this problem, the common denominator is a 2, so I'm going to take out a 2. So I have x squared plus 2x minus 3. And this is a pretty easy factoring after this. It's x plus 3, x minus 1, 3, take away 1 is positive 2. Do not lose the 2. Bring down the 2. And finally D, grouping. That's what this is grouping. It's really greatest common 3 times. And you might be like, how's it 3 times? Well, we'll start first, second. So let's get started. So we take out a y, and I get x plus 3. And then go to the back. Now for this to work, it has to be x plus 3. Take out a negative 2, and you have x plus 3. And finally, the last common factor, what do you see in both? I see x plus 3, so that comes out. And whatever's left put together, so it's y minus 2. And that's the 4 factoring. Let's go on to number 7. Alright, so number 7, solve by completing the square. Now, different than quadratics. We don't want it set to 0. So when we do complete the square, I want the regular number, the constant, the x squared minus 8x, I want the regular number to the other side, so negative 12. So I keep the variables to the left and the regular constants to the right. And so now here what we do is, now it depends on who your teacher is, right? So I just go like this, x minus whatever half of 8 is, so I say x minus 4. Now, if I actually FOIL this out, it does not look like this. If you actually do it, now don't write this down. If I actually FOIL this out, it would look like x squared minus 8x plus 16. So what's missing here is the 16. So I'm going to put plus 16 over here. But if you do it to the one side, you have to do it to the other side. So this is why I'm going to get 16 minus 12 turns out to be a regular 4 on this side. Now, to get rid of the square, we square root. So we get x minus 4 equals positive negative rad 4. And let me just get rid of this. We square root it. We can actually do the square root. So x minus 4 equals plus minus 2. Move over the 4. 4 plus minus 2. And then actually do it. So it's 4 plus 2 is 6. 4 minus 2 is 2. This is a set of numbers, so I'll put it in squiggles. S for set, S for squiggles, or we call them braces, or whatever you want to call them. Or just write out x is 6, x is 2. Either way is good. Number 8, find the center and radius of a circle. Now, it doesn't look like a circle how you normally used to seeing it, because in this problem, the x's and y's are mixed together. So first thing is you're going to put the x's with x's, the y's with y's. And I give a little space here like this. And while we're at it, why don't we just move the 1 over to the other side? Call it negative 1. All right, so we're going to complete the square twice. 1 over here, and then 1 over here. 1 for the x's, 1 for the y's. So let's think about this. So half of 2 would be 1. So it's x plus 1 squared. All right, now, if I doesn't match up to this, so whatever the square, the back number, plus 1 turns to a plus 1. For what we're doing now, for completing the square with quadratics and circles, it's going to be plus, we're adding. So I'm going to add 1 to the other side to balance it out. Now this one, y minus half of 4 is 2. So I'm going to square the 2. So it would be, I'm missing a 4 if I FOIL it out. So plus the 4, clean this up. This is the equation of a circle. And that's the notation. They didn't ask for the equation. They said find the center and radius. So I need this to say the center. Now remember, the center is a point opposite what you see. So the center would be negative 1, positive 2. And the radius would be square root of 4, which would be 2. That's a good question. Double complete the square. Let's go to the next one. So the last two questions. Number 9, discriminant for this and describe the nature of the roots. So what you need to know is the formula for discriminant is b squared minus 4ac. It's the inside part of the quadratic formula. Do not put the radical on it. Do not put the radical. Now on the front side you had all the choices also. So here I'm going to first have to set it to 0. So x squared plus 6x plus 8 equals 0. So I got a is 1, b is 6, c is 8. I'm going to put it into the formula. So it's going to be 6 squared minus 4 times 1 times 8. Clean this up. The answer is 4. 4 is a perfect square. That's important because that means our roots will be real, rational, and equal. Excuse me, unequal. That was bad. Unequal. So the choices are equal roots is a 0 for discriminant, imaginary is negative, real, irrational will be non-perfect squares. And finally, the last one, solve. So we can solve this by, that's a cube. So I can oh, we always look for a greatest common factor. If I look here, I can take out an x. So I get x squared minus 2x minus 8. Now it looks a little better for me. I can break this down again. So it's x, 8 is 4 and 2. Sign in the middle goes with the bigger number. Don't lose the x over here. Still equal to 0. So now I got to find out what would make any of these three parts the 0. Well, for the first part, x by itself means x would have to be the 0. In the middle, to make x minus 4 turn to 0, x would have to be positive 4. And finally, for the third one, x would have to be negative 2. And that's it. Hope the video helped. Have a nice night.